So a linear model was defined as y hat equals to mx plus b. If you have a scatter plot, some points with some noise, and they follow the linear pattern, y hat equals to mx plus b, we use that. In this case, your m as slope or average rate of change is positive. So that's why we had an increasing line. What if you have this pattern? Suppose your points in scatter plot with some noise, of course, are following this pattern. They are going downward. And the best model is a linear model. Y hat equals to mx plus b. But in this case, since the line is decreasing, the trend is decreasing, we say that, hey, our best fitted line has negative slope. So slope is m as the slope is negative. Then we start talking about different patterns, different data, different scatter plots with actually different model. So we talked about exponential model. Exponential model, remember that they define the model as a mathematical equation y hat equals to a b raised to exponent x, and based on our b, if b is a number greater than 1, we saw that we have an increasing pattern, like the population of rabbits. Or if b is a number between 0 and 1, you get a decreasing pattern, like the level of radiation. So we had this pattern, increasing pattern in this case. So our model is going to be an exponential model. It's not linear, it's different from linear model. And in this case, we say that, hey, b is a growth factor. B is greater than 1, and b is a growth factor, like the population of rabbits. Or we also saw the level of radiation example, which showed that the amount of radiation was decreasing, following a decreasing pattern like this. And in that case, we saw that b is a decay factor. B was a decimal number, a very small number between 0 and 1, and we have a decay factor. Why we define y hat? Because we want to make predictions about other values. Today we're going to continue having another example, analyzing that example, see what information we can derive from our pattern and eventually mathematical model. Facebook membership. The online social networking site Facebook was launched in February of 2004. From 2004 to 2010, Facebook membership grew rapidly as its popularity increased. Facebook tracks its number of users closely and uses this data to generate new business opportunities. The table and graph below provide information about Facebook membership measured by number of Facebook users for selected months between December 2004 and July 2010. The membership counts represent the number of people who are Facebook users. The numbers are given in millions, so when you see number like 5.5, it represents the number of people who are Facebook users, and it is in millions, so you get 5,500,000 users. Let us move on to the next page. Very well. Here we have our table, month, year. December 2004. And of course, we need to have our X as our variable, which in this case counts as the number of months since February 2004. So since February 2004 to December 2004, we have 10 months. And Facebook actual membership in millions of users was 1 million. Let us move on to second row. Month, year is now December 2005. The number of months since February 2004 represent X is 22 months. How many members? 5.5. 5,500,000 users. Then the next row is December 2006. How many months since February 2004? It is 34 months. How many users? From 1 million users, you have 12 million users after 34 months. So as you can see, this model with scatter plot on the right-hand side shows an exponential model. This is not a linear model. It doesn't follow a linear trend. It is an exponential trend. So we have information until July 2010, 77 months, and with 500 million users. So in this example, the exponential model is given to us. Facebook membership can be modeled by the exponential curve y hat equals to 0.8, 1.09 to the x. Let us take a look at the board. In example, for Facebook, y hat is given as 0.08 times 1.09 to the x. Okay, let us analyze this. What do we have? We have the initial amount, which is A. Your A is 0.08 million users. Then you have B raised to exponent x, B, which is 1.09. So as you can see, your B is greater than 1. Greater than 1. What's the meaning of that? It means that we have a growth factor. So we have a growth factor. What's the meaning of that? It means that we should be an increasing trend, which we saw in our scatter plot. It means that we have an increasing trend. And by looking at our graph, let's take a look at our graph. You see, we read the graphs from left to right. From left to right, this is an increasing pattern, increasing exponential pattern. So let us move on, try this. 1. According to the exponential model, when did Facebook's predicted membership exceed or go grow larger than 200 million users. What do the values 0.8 and 1.09 in the exponential model mean? Let's take a look at this. To answer question 1, we want to know when we had more than 200 million users. So the number of users, we look at the last column, 1 million, 5.5 million, 12, 20, 50, 100, 150, 175, and we got to 200 million users. It was April 2009. So we can write question 1. In April 2009, we see 200 million users. So after that month, the number of Facebook users exceed 200 million. And to answer question 2, as we saw on the board, let me type it here for you, 0.08, which is equivalent to 800,000 users, shows the initial membership in Facebook. And B, which is equal to 1.09, represents the growth factor. Question 3. Use the exponential model to predict. So your job as a statistician is to predict Facebook's membership in September 2007, or 43 months after it's launched, and in January 2010, 71 months. 4. Use the exponential model to predict Facebook membership in March 2011. Guys, note that you don't have information about 2011. It stops at July 2010. So we are using this model to make predictions. And 5, consider the predictions you just made in your answers to question 3 and 4. Which do you think is more reliable? And 6, membership data was not reported until 8 months after Facebook's launch. Use the exponential model to predict how many users Facebook had when it started in February 2004, or month 0. Do you think it's realistic? So question 3 says, what if your x is 43? What if your x is 71? What would be the p-hat? What would be the number of members? If x is 43, what is your predicted membership? We have a nice formula. Wherever you see x, you plug in 43, so you have 0.8 times 1.09 raised to 43. And the same for x equals to 71. To find the predicted numbers of memberships, you just plug that into the formula, 0.8, 1.09. Now it is raised to a new exponent, 71. X represents the number of months after February 2004. The number of months. Very well, excellent, excellent, well done. So 33 million and 363 million. Very good, thank you everyone. Million users, and approximately we have 363 million users. So this is the answer to question 3. How about question 4? What would be the number of memberships in March 2011 after 85 months? Question 4. What if your X is 85 months? What would be the number of memberships? How many memberships do we have? 0.8, 1.09. Now it is raised to a new exponent, 85, which is roughly, what do you have? 1,000, very good, and very good, very good. 1,214. Million. 1.2 billion users. That's huge. Let's take a look at our table. After 43 months, roughly 44 months, you have 50 million users. After 71 months, 70, 72, you see 350 million, in between 450 million. And after that, we don't have information about 85 months. It stops at 77 months. So after 77 months, you had 500 million. And now we made the prediction that after 85 months, it's going to be 1.2 billion users. So which one is more realistic? Which one is more reliable? Is it 3 or is it 4? And finally, if you consider the membership at the very beginning month, is this realistic? Is this a reliable value to you? So for question 5, which one is more reliable? The answers to question 3 or the answers to question 4? And for question 6, the initial number of memberships is 800,000 users. Does it make sense? A is 0.08 million or 800,000 users and month of February 2004. Does it make sense? So to answer question 5, you can say that prediction in question 4 is not very reliable. What's the reason? Very good. Thank you, Helen. So to answer question 4, you can say that, to answer question 5, you can say that the information about question 3 is more reliable than the answer to question 4. Why is that? What's the reason behind it? We're trying to extrapolate. That's the reason. That's why the answer to question 4 is not that reliable. And finally, for question 6, does it make sense to say that, hey, the initial value is 800,000 users? It's not realistic as well. So to answer question 6, let me write it in the chat for you. You can say that the initial value in exponential model, which is represented by 0.8 million or 800,000 users, is probably not realistic. Suppose somebody asks you, what was the percent increase between 2 months, 2 years for Facebook? How do we calculate that? To calculate the percent increase and percent decrease, we actually follow this formula. Percent increase. In this case, we have to form a fraction. On top of the fraction on your numerator, since you're actually trying to find the percent increase between 2 data sets or 2 numbers, 2 y hats, you have a new amount, and you have an old or previous amount. Old amount. And you divide that by what you had before or old amount. And eventually you multiply that by 100% to get the percent increase. This is the formula that we are following. So in this question we have, what was the percent increase? So this is the question. What was the percent increase in Facebook membership? In Facebook membership between May 2007 and the next month, June 2007. First of all, we need to find our X values. What is our X when you're working with May 2007? What would be your X when you have June 2007? So for each of these X values, you get 2 different X values. What is your Y hat? What is the number of users? By looking at our table, we only have information about April 2007. But the question says, what is X for May 2007? April 2007, since February 2004, we have 38 months. So what would be your X value if I just jump 1 month ahead? So my X is 39. What would be the Y hat? What would be your predicted number of membership? We have to plug that in, use our calculator, and to find this number of membership. So you have 39 and calculate this. So what do you have? How many members do you have? Approximately? $23.05. Thank you so much. Excellent, excellent. So here you have 23.05, and it's just approximation. So instead of using equality, we use approximation million. How about the second one? Now you're looking at June 2007. So what would be your X value? Your X is now how many months? 40 months. Very good. Thank you. Now your X is changed to 40. It means that the number of users is going to follow the formula 0.8, 1.09 raised to this new exponent, which is 40. Here we go. So what do you have? $25.13 million. Excellent. Thank you so much. 25.13 million. Okay, we have all the information that we need to find the percent increase in the number of memberships in Facebook between May 2007 and June 2007. So note that 25.13 million is your new amount. This is your new, and this is your old amount, old value. So let's plug those in. Here we get 25.13 minus the old amount, which is 23.05, divided by the old amount, which is 23.5. Then we multiply that by 100%. So please do the calculation. (9.02%). Excellent. Approximately 9.02%. This is your percent increase between May to June 2007. Thank you, Cynthia. You need to know that an exponential model indicates that for every 1 unit increase in X, the value of your Y hat, or the predicted value, increases or decreases by a fixed percent. The value of B, the growth or decay factor, is related to the percent increase or percent decrease. You take your B minus 1, so we are subtracting 1 from B, and we define the growth rate or decay rate as a decimal. By multiplying that by 100%, we can represent that as a percent. Question 8. Facebook membership in July 2010 was approximately 500 million users. Use the growth factor of 1.09 to predict the Facebook membership in August 2010. 9. In the homework for the previous lesson, we looked at an exponential model that predicted the amount of acetaminophen in milligram in a person's bloodstream 8 hours after taking the medicine, which followed this formula. This was an example of exponential decay since B is less than 1. Use this model to answer the following questions. Use the decay factor B to determine the percent decrease in the predicted amount of acetaminophen in a person's bloodstream each hour. Use the exponential model to determine the predicted amount of acetaminophen in a person's bloodstream after 2 hours and after 3 hours. Give your answers to 2 decimal places and finally find the percent decrease. So since you have your model as y hat equals to 650 times 0.45 to h, your h is 2 hours, your next h is 3 hours, and we find the amount of acetaminophen in the blood. So in this example, we have our model y hat, which is equal to 650 times your B is 0.45 to the h. You know that h is equal to 2. Now you need to find your y hat, 650.45 to 2. What is your y hat? And if h after 3 hours, what is the y hat? The amount of acetaminophen in the blood, 650 times 0.45 raised to 3. What are these two values and how do you find the percent decrease? We have the formula for percent increase, and what would be the percent decrease? So after 2 hours, we have what's your calculation? After 2 hours, after 3 hours. So we expect this to get lower and lower, the decreasing amount. Very well, excellent. 131.63, thank you. So approximately 131.63, thank you so much. And after 3 hours, it must be lower than the first one. Okay, thank you, very well. 59.23, thank you so much. 0.23. So how do you find the percent decrease? Exactly following the same formula. You had percent increase, now you change it to percent decrease. Let us find the percent decrease. New amount, which is 59.23 minus the old amount, which is 131.63 divided by old amount, 131.63, 100%. So what is this approximately? What's the percentage? The percentage is approximately, you get a negative, very good. This negative sign means that you get a decrease. So it should be a negative number, a negative point, very well, 55. What's the meaning of this negative sign? This negative sign shows the decrease. Negative sign means we have decrease. So you can say that, hey, I have 55% decrease. This is the percent decrease. Excellent. Well done, everyone.